copy segments as well as compare segments and circles. So before we get started with the lesson, we're just going to kind of look at this do now to get you used to what we have to do in geometry in terms of being faced with a problem and working through it in different ways. So there's this story with Karl Gauss, and that's this gentleman right here. When he was 10 back in 1787, the story goes that he was sitting in his classroom and he had finished a test. So to keep busy, his teacher just said, "Hey Karl, why don't you find the sum of the numbers from 1 to 100? So essentially she wanted to know if you added every number from 1 to 100, so 1 plus 2 plus 3 plus 4, so on and so forth, what would the sum be?" And in no time, he figured it out. And she was stunned. She couldn't believe it. So what we know is that Karl did not add 1 plus 2 plus 3 plus 4 plus 5 plus 6, so on and so forth, because back in 1787, there weren't any calculators to do any of that calculation. So what we'd want you to do is to pause the video right now and see, can you find the sum of the numbers from 1 to 100 without adding 1 plus 2 plus 3 plus 4 plus 5, so on and so forth. So pause and do that. And then I'm going to, when you're done, play this, and I'm going to go through how to figure it out. Okay, so now you kind of probably have racked your brain and try to figure this out. And here's what Karl Gauss did. Karl said, well, I can't add 1 through 100 through, with any sort of material. So what he did was he figured if I start at 1 and I laid out all the numbers all the way to 100, he saw that there was this relationship. And he kind of worked in pairs. He said, okay, if I start at 1, I could pair the number 1 with the number 100. I could pair the number 2 with the number 99. I compare the number 3 with the number 98. And every time he did that, he saw there was a commonality. When he added the numbers together, 2 plus 99 sums to 101. When he added 1 plus 100, it summed to 101. When he added 3 plus 98, it summed to 101. And what he figured out is if he kept on doing this, there wound up being 50 pairs that summed to 101. So if there are 50 pairs that sum to 101, well then, if you add them all together, what do you get? So instead of adding 101 plus 101 plus 101, he did something else. He did 50 times 101. So again, back then Karl Gauss said, well, I know I don't have a calculator, right? So he couldn't figure this out by using his calculator. So he did this, and he said, okay, well, 50 times 101, you can figure that out because you do 50 times 100, right? And that's 5,000, and then just another pair of 50, so he comes to 5,050. So right there, we know that the sum of the numbers from 1 to 100 is 5,050. We like starting with this because in this class, you're going to have to look for patterns. Geometry is all about patterns. Math is all about patterns. And then from there, you work with the patterns to kind of work through the problem. So that's just kind of how we got started with this. But what we're really working with this unit, like we had said yesterday in the last lesson, are constructions, and we're always going to be working with your compass and your straight edge. So you have right now a ruler or a protractor. We don't say that it's a ruler or protractor. We always refer to it as a straight edge. And we have gone over why, and I'll just remind you again, is you never use the straight edge, the ruler, to measure, right? So I'm going to do this in red. So not used to measure. So never are you going to say, hey, this looks to be about 3 centimeters, let me measure it, right? You're not using the straight edge to measure. The straight edge is merely used to draw straight lines or to connect points, but you're not going to say, hey, this appears to be 3 centimeters, let me measure it, okay? And your compass is that tool over here, right? You have your needle and your pencil. The compass is used to draw arcs. Remember, in geometry, arc marks are your work. So in this class, I'll put that kind of up here. Arc marks equals work. So back in algebra, you had to show your work. So arc marks is how you show your work. Okay, and you use your compass to do that. Okay, so what can you create using your compass? And again, we kind of went through some of this stuff. The two main things that you're going to create using your compass is going to be circles and arcs. So you can do full circles with your compass. So you can create that, right? Make a full circle. And we know from yesterday, really, I probably should have started that with a little center point right there, right? Or instead of circles, you can make pieces of a circle known as arcs. Right? So that's what we're going to work with. Now, how are we going to use circle and arcs and even our straight lines to construct things? So ask yourself, well, what can we construct using circles and arcs? And you may be thinking, well, that's a little bit weird. How am I going to do anything except have a circle or an arc? Actually, what we're going to be constructing, it's quite interesting. We're going to be constructing things like triangles. We're going to be constructing squares. We're going to be constructing hexagons, parallel lines, perpendicular lines, so line relationships. Really, we're going to be constructing a whole lot. For this specific lesson, we're just going to learn how to actually copy segment lengths. But as we go forward, these are all the different relationships that we're going to create, like parallel and perpendicular lines, hexagons, triangles, squares, and so on. All right. So before we get started, we have to talk about a couple of key terms. So you're going to see either the term sketch or draw. Vice versa, you might see the term create and construct. So there is a difference. If I ask you to sketch something or I ask you to construct something, I mean something very specific. So if you think of a sketch or a drawing, right? And I try to think of like sometimes art class, a sketch or a draw. So when you're sketching something, in your mind you should be thinking, okay, a sketch is something that's just a quick diagram. Right? You don't need to use a compass or your straight edge. Okay? So if we say sketch or draw and you use your compass, you've actually created something or you've actually constructed something. And we will, unfortunately, have to take points off because we were specific. We said to sketch something. We didn't say to construct something, right? So if we say to create and construct, now this must be very precise. And precision is by using your compass and straight edge. Okay, so really that's the difference that we're going to see. I would say at this point, kind of have it ingrained in your mind to sketch something is like, again, that quick little drawing, but to construct or create something, it's precision. You have to use your tools. If you want to construct, construct a house, you're not going to use, a piece of paper. You have to use some tools. You need a hammer, you need some nails, right? So that's the difference there. Construction, you need tools. Sketching, just quick. Okay? And again, at any point you can pause this video, take your notes, re-listen if I'm going too fast. Okay, so now just get used to using your compass. Pause this and see if you can create a smiley face using only your compass. So only use your compass, create a smiley face. Go ahead and pause. And now compare to what we have here. Here's my smiley face. So I have my big circle, my two smaller circles that are identical, my little nose, and then an arc here. Just to kind of point out, the smaller the circle, the smaller the width of the compass, the harder it is to actually use the rotation of your wrist to make that circle. So when you're making small circles, you may want to move the paper instead of moving your hands. The next is, can you construct the Olympic rings? So if you don't know what the Olympic rings look like, here they are, right? There are 5 rings. 3 on the top that don't overlap, and then 2 on the bottom that overlap only the rings on top. They don't overlap each other. So try this out. You can pause the video and try to construct the Olympic rings. Again, there are 5 identical circles, 2 of which intersect the 2 above it. Okay, and now we're up to our first construction. So the first construction is known as copying a segment. So here we have to copy the given segment. Now, the segment I have is segment AB. I know it's a segment because it has endpoints. So if you look to the side over here, here's how you show notation or symbol form of segment. So you have your 2 endpoints with this little segment line on top of it. There are 2 more notations that we're going to show you right now, and the first one is point, and then we're going to talk about array. So to notate or show the symbol form for point, it's actually just a point and then whatever the letter is. So we have point, and then we'll just say point A, for instance. So we get point A. It's a little big. Make this a little bit smaller, and I'll make it red. Okay, so we have point A. And that's how you can show a little symbol notation. So you'll see it. You label a point by just using the uppercase letter, so point A. And then you have array. Array, we did when we did concentric circles, that has a starting point and it extends infinitely in one direction. So to show array, it's like an arrow. So we have our arrow on top. And then it includes 2 letters, the endpoint, and then whatever point it goes through. So I'm going to then say we'll have, for this, I know we're going to have Ray, AB. And both should then be capital. So that's how you show array. Okay? You will be responsible for the notation now. When you see this, it's read as Ray, AB. This is read as point A, segment AB. So let's go through how to actually copy segment AB. So there's 2 ways. The first way is by using a point. Okay, so you're going to start with the point. You're going to start with the end point of the segment. So we're going to start with point A. So I need to take my pencil. I need to put a point. And now this is going to be new. We can't call our point A. And the reason why we just can't say point A is because A is here. So we're going to call it A, and then put this little like apostrophe. It's called a tick mark. A prime. So now this is read as A prime. So it's basically like A, but it's its copy. All right, so that's how you read this, A prime. So we're going to start with A prime. And how do you copy something? Well, we have to use our compass. So we're going to go ahead and take our compass, and we have to find the width of AB. So you're going to line the needle of your compass on A, and you're going to open up that pencil and stretch it to B. And I always like to show that I've measured AB by swinging a tiny arc. Well, this isn't swinging. There we go. There it is. So I swing a tiny arc. Now, I'm copying it. So if I was to copy this, it means I don't want to move the width of my compass. I'm just going to lift it up and bring it down to A prime. And I'm going to swing a tiny arc. There we go. Okay, so I've took this measurement and I simply copied it down here to A prime. My final job now is to just now put a point along this arc anywhere. So I'm going to pick a point right here. And what do you think I'm going to name that point? If I've just measured from A to B. I'm going to name it B prime. Now I'm going to go ahead and label this B prime. And I just copied segment AB. But I'm not done because this isn't a segment. I only have 2 endpoints. Finally, now I have to take my straight edge and I have to connect from A prime to B prime. And there it is. So that's how you copy segment AB using a point. Okay. The second way is to now use array. Okay, so if I were to use array, I need to then start with a point still. So I'm going to go back here, and I'm going to put a point, and I'm actually going to name this point A double prime. So it's not like A prime up here, it's A double prime. Because if I said A prime, I'm technically talking about this. Okay, and now I need to draw an array. So the way you draw an array is you take your straight edge, and you start at A prime, A double prime, and you draw a straight line with an arrow, and you make it pretty long. The reason why we make it long is because I have to account for how wide my compass may be. I don't know right now. I mean, we know because we already did AB prime, but I just want to make sure I make it long enough. That's usually the first error is students don't make it long enough. All right, so now I'm going to go back up here, make sure my compass is at the right width. So here I have it, AB. Good, so I measured it. Bring this down. Here, swing my arc. Perfect. And now I know where B prime should be. B prime is going to be at the intersection of the arc and the ray, right here. And now I'm just going to label this B double prime. Bam. So I just copied segment AB in 2 ways, using a point and using array. And remember down here, this is read as A double prime. And we have B double prime. Okay, and again, the cool thing about this video is you can stop and rewatch anything that I just did. Okay, so now let's take some notes so that you have this using some words. So first thing is to copy a segment. This is what you can now fill in. You're going to start with either a point or array. So that's what you can fill in. So you're going to start with a point or array. Next, you have to open the compass to the original segment length, right? We had to open it to AB, that original segment length. Needle on one endpoint, pencil on the other. Okay, now without moving the compass width, we have to now move it to the new point or array, depending on how you started. But either way, you're moving it to that new endpoint. And regardless, you swung an arc. After you swung the arc, you just use your straight edge to connect the point to any point on the arc. And that's it. So just a couple of kind of simple steps. You can go back and you can reread and compare, and you can try to do this again. All right. So how can I make sure that I have 2 equal segment lengths? So let's just kind of, for a little like giggles here, suppose I draw this and this, and I want to compare the lengths. How could I make sure, or how could I see if I'll call this like segment 1, right? We don't ever really name them like this, but this is like 1 and this is 2. Well, actually, let me call them A and B so we don't think I'm measuring anything. Okay. So how can I compare to see if they're the same? Now you can't use your straight edge. So you're not allowed to use your straight edge. Do not use straight edge to measure. Okay, so we're not using our straight edge. We actually have to use our compass. So what we're going to do is I'm gonna type it first so you have your notes written down, and then I'll show you what we're gonna do. So we're gonna use the compass. So we're going to use and compare compass width. So the compass width. And this is what I mean. I'm going to go up here to the segment that I labeled A. I'm going to take my compass and I'm going to go from this endpoint here to this point here. I'm going to swing a tiny arc. Okay, so that's how long this segment A is over here. When I come over here, I'm going to measure. So are these two segments the same? And the answer is no. I saw that I would have to actually open this compass wider to be the same length. So I'm right here. These two segments are not equal. And you can tell when I sketch the arc, right? It's going through the segment, but not at the end. So you're going to use your compass, and that's how we want you to use your compass. That's how your compass helps you to compare different lengths, by opening it up and using the compass width to compare. All right. Let's go, keep going, and actually, if you can, oh, what happened to the? Oh, here we go. We can do this now. And we're gonna, before we identify and sketch or draw, I should say, two circles, we're gonna ask you if you remember the different parts of a circle. So in order to identify the different parts of the circle, what's most important is that we have a center of the circle drawn in, and we do. So the first thing is the diameter of the circle. So the diameter of the circle is a segment that goes through the center from one side to the other. Okay, so that's the diameter. So it goes through the center. It's a segment. I should put here actually. A segment that goes through the center from one side to the other. All right, so that's what our diameter is. That's how I know what a diameter, if I have a diameter. All right, so now let's actually sketch in the diameter. So I have my center. So I just need a segment that goes through the center from one side to the other. So I'm going to go like from here to here. This is quite a thick line, so let me make this a little thinner. There we go. There's our diameter. Perfect. Done. Okay, the radius. So the radius is a segment that goes from the center to any point on the circle. Right? The radius is actually half the diameter. So the radius is going to be half the length of the diameter. And we'll kind of get to what that means in just a minute. I'll give you an example. So here's the radius. So I do the radius from going, say, this one in, copy, paste it over here. So as long as I start the center, I can take the endpoint and put it anywhere. So there's your radius. Okay. So for instance, if the diameter was 10, the radius would be 5. If the diameter was 2, the radius would be 1. Okay. And then finally, when we're talking about circles, we have an arc. And remember, the arc is just a piece of the circle. So if we're talking about an arc in this circle, we could just be talking about an arc that goes from maybe here to here. Making now this color, so like along here, this could then be the arc. The arc just goes along the outside. It's just a piece of the circle. It's like cutting just a piece of the circle. And there we have that. Okay, so then we're just going to kind of wrap this up by now saying, how can we construct two identical circles, and then how can you make sure that they are actually identical? So constructing two identical circles, if we actually want them to be identical, what has to be the same is the radius width, right? So radius must be the same. So you're going to start both ways. How do we start this? We're going to first start with the point. Bam. And I'm going to take my compass. And since I'm creating this circle, I can make it whatever width I want, however big. So I'm going to make it just a little bit big. And swing my circle. Now I want a circle that's going to be exactly the same. So I'm going to put a point. I'm not going to change the width of my compass. Bring it over here. And I do the same. So now how can I be sure that these two circles are the same or identical? That's what it says here. How can you check that they're identical? It's kind of similar to the segment in terms of we're going to use the compass, but we're going to use the compass to compare something different. So we're going to use the compass to compare the length of the radius or diameter. You could do both, or you could just pick one. So I'm going to use the compass to compare the length of, I'll do the diameter. So I'm going to go up here. First thing that would be that I have to do then is to draw in the diameter. So I'm going to go from here to here. And now I'm going to take my compass and I'm going to measure from here to here a little bit more. All right, I'm actually just going to change the color. So I measure it. Boom. Okay, so that's how long it is. And then I'm going to go back and I'm going to draw in the diameter here. Now it doesn't matter how you draw the diameter as long as it goes through the center, because the length of all diameters in the circle are going to be the same. Just kind of make this a little bit like that, like this, and see when I draw, yep, it's right at the end. Perfect, and they're the same. So you use the diameter width to compare, and they're the same, so then the circles are identical. Okay, so that finishes up copying a segment as well as comparing segment lengths, which is lesson 2. You do have a practice to submit after this. So if you go into your Google Classroom, you're going to try those questions on a separate sheet of paper, take a picture, and upload that to the Google Classroom to get credit for the practice for lesson 2. Remember, you can rewind and rewatch the lesson, but if you have any questions, feel free to email us.